So that one ended right at the worst time.
Yeah.
We were almost done with part A.
Well, we're back to finish part A. Hello. So Austin Caudle again, success coach. Miss April, your teacher. Back to continue 3.2 and 3.3. All right. So like I was saying, the x input is 144. So we're gonna plug that into the equation, and when you get an x value or a y value, you can plug it in and solve for the other variable. Generally, it's you find x, you plug it in, and you solve for y. So if we know x is 144, we plug it in. We're going to go to Desmos. And to do square root on Desmos, there's a keyboard shortcut. You can do SQRT and 144.
So squirt.
Yeah.
144.
But like without vowels.
There's
no vowels. Okay, I had to double check.
Yeah.
So if you don't recognize it as a perfect square, that is totally okay. You can always use the calculator, and in this case, it would be 12. Yay. And part
Notice part B was skipped because part B is the exact same process.
Right. So you can use the process from part A to do part B. And same with part C. You can use the process for part C to do part D.
Yes.
Okay.
Yes.
Just making sure. How far down the river from the source of pollution does the plume reach 1/4 of the way across the river? All right. So 1/4 down the river. The river is 100 meters wide. So we're going to do 1/4 of 100. That's 25. But that's the output because that's the value of the pollution downriver.
Now, how did you get 1/4 of that being a 25?
Good point. I did it in my head. Sorry. Okay, so 100 you can multiply
Times 1/4
times 1/4,
yes.
or you can
divide
do 100
divided by 4.
divided by 4. And that's kind of what I did. But you could always put that into Desmos as well. If you don't want to do it in your head, all good. And the slash that's underneath the question mark on the keyboard, that will help you make the
Good.
fraction portion. So that will be 25.
That was good information.
Yeah, I like to do the keyboard shortcuts when I can.
Amen.
So 25 equals square root x. And we're using inverse operations to try to solve.
So the opposite of the square root is?
It's a square.
Yes.
So we do the opposite to solve, isolate the variable. When we're solving an equation, we're going to use the order of operations, but the opposite. And then 25 squared will be that value, and we can, oopsies, do that on Desmos. So 25, you can do 25 times 25, and the times or the multiplication, you can do shift 8 on the keyboard, and that is multiplication. You can also do square, you can do 25, you can hit shift 6, that's the little caret, and that is the exponent to do 625 or 25 squared. Yay. You guys are getting all the shortcuts all at one time. They're probably going to be like, what? All right. So that's going to be 625 meters down the river. Woo. All right. Any questions, direct them to Miss April. Or me, if I'm available, but Miss April. All right, so number 6. We've got t equals 3 pi. And then we've got times the square root of L over 30. And I know it's times because whenever you have a letter, it's kind of hugged up to a symbol or a number, that's multiplication if there's no symbol. All right, so we know the value for pi, 22 over 7. Just like any equation, if you know the value, you're going to substitute it in using parentheses. You take the symbol or the letter out and you plug the value in to the parentheses. I also know that T is 4. I'll be solving for L. I like to underline and box things to help me focus on specific areas, and feel free to use that too if it helps. We all have our own kind of jams that help us out. So I'm going to put 4 in parentheses, I'm plugging in T, and then just carrying everything else down. And you're probably thinking, all right, Austin, where are you going with this? Because this looks a little crazy. We're going to simplify. We're going to simplify and we're going to solve for L. Okay, we're going to use the order of operations, a little bit out of order. PEMDAS, you probably heard that a lot. I'm sure Miss April has brought it up to you.
Not in that form.
Not in this form, but that's okay. This is how we're going to solve for L. We're going to start with parentheses first, then exponents. We will combine like terms on the same side if we can, if that is available, because when you apply parentheses or exponents, you're kind of creating new terms, right? So if you can simplify those, you should. Makes it a little bit easier. So combine like terms on the same side. It is hard to write on this. I'm like, oh, okay, this is a little difficult. That's okay. I have a little practice too. That's the sad part. It's still difficult. I know you have practice as well. Because, like, the equal sign, it breaks things into team left, team right. If we're on team left and we can put something together, we don't have to do opposite. They're on the same team. So always look for that when you have the chance, when you're in step 1 and 2 right after. Then we go to stage 3, addition, subtraction, but we do the opposite. The goal of stage 3 will be to get our letter jazz on one side, number jazz on the other. Then we will do multiplication, division. Once we have letters on one side, numbers on the other, we isolate, solve for the variable. Sometimes you can be in stage 4 and get kicked to stage 3 again. That happens sometimes. But you follow this order. I use this every time I solve a linear equation, and that means there's no exponent attached to any letters. Always works. It's my favorite. I mean, I think you use this too. So
Not exactly. I use something slightly different.
okay, I feel like I
Yeah.
came up with this one. It is a little bit different than you see it. So, all right. So first we get rid of parentheses. There's nothing inside the parentheses with the 4. There's nothing outside the parentheses to distribute or multiply in. So I really don't need those parentheses. In this case, we've got the 22 over 7 in this parenthesis. There's nothing else in those parentheses, but there is a number right on the outside. So we're going to multiply that into the fraction. So we're going to do 3 times 22 over 7, which you can do in Desmos. 3 times 22 over 7. And then you hit this button to turn it back into a fraction. Because that's not a nice, clean, terminating decimal, right? It's not like it's 9.4. And we don't want to round it when it goes on forever and ever like this. And there's no pattern. Okay, so we're going to turn it back into a fraction. We're going to have it as 66 over 7. And we still have to carry down that whole root L over 30. Because our L is buried underneath that square. Just going to be a little bit of work to dig out. All right, so we don't have any more parentheses. We're good there. We don't have any exponents. Good there. We can't really combine like terms on either side because this is a number, this is kind of a root, and then this number's by itself. It's not like I have 2x plus 3x on the same side and I can add them together, right? We've got some multiplication on the right. This is by itself. No like terms that I can combine. Then I move on to stage 3. Addition, subtraction, but the opposite. Try to get my letter jazz on one side, number jazz on the other. I kind of already have this. I would consider this to be kind of a variable term because it has L attached. So what I'm going to do is I'm going to move to stage 4, so I don't really need stage 3. And I'm going to divide by 66 over 7. So I'm trying to get that root by itself. That would be the first step. Can't really add or subtract anything to the other side. So we're
Why are
using
you doing that?
to get the root part by itself.
Because it's multiplied to it.
Yes. Because no symbol and that fraction is right in front of the root, that's multiplication. Whenever you have a number next to a letter or a symbol, it's multiplication if there's no sign. It's implied. Yeah, that's always tricky. And I always take that for granted because I'm like, I just know.
Yep.
But you're like, how do you know?
Uh-huh.
It's because I'm psychic. No, I'm just kidding. So this kind of cancels out here. And we're going to do 4 divided by 66 over 7. I'm going to do the 66 over 7 in parentheses. So it keeps it together. Then hit that fraction button. And we've got 14 over 33. So 14 over 33 is kind of the outcome on the left side. And now I am left with that root, L over 30. Well, I need to get rid of that root. I need to get rid of that root to try to isolate the variable because, like I said, L is kind of buried under there. So the opposite of root or square root is square. So I'm going to square both sides because if I'm doing opposite, whatever I do to one side, I have to do to the other. So I'm going to do 14 over 33 and I'm going to square. I can do that in parentheses, right?
Mm-hmm.
And whenever you square a fraction, it's kind of applied to the top and then the bottom. So it's 14 squared over 33 squared. And that's going to be 196 over 1,089. It's a big number.
Yeah.
106.
Wait. 196.
Just kidding. 196. I knew that. So 196 divided by 1,089. Too many ones and nines, so I'm just kidding. Does that look like an 8?
Uh-huh. Sort of.
You're like, that
There we
depends.
go.
That depends.
Yeah.
Equals L over 30.
Yes.
And we're so close to having L by itself now. Because now all we need to do is Miss April's shortcut.
Yeah.
Yay!
So let me explain. We could do what's called cross multiply. And I used to teach cross multiply in the normal method until I had this 8th grade student say, "Why don't we do this?" And it's such a beautiful shortcut, and I felt stupid because I was already like almost 50 and had already gotten my master's, and no one had ever shown me this shortcut, and I had never figured it out myself. So yeah, so I could take 196 times 30 equal 1,089 times L, and then still divide by 1,089, or I could just go ahead and multiply these and divide by that in one step. So
I was gonna say, like, that would create an extra step.
it is an extra step that's
Right.
unnecessary.
Because I was thinking, like, oh, we could multiply by 30 on each side, but yeah, well, you could totally do the cross multiply and then divide by the bottom number. That's convenient.
Yeah,
I like that.
I do too. And it was my 8th grade student that was smart enough to figure it out.
That's awesome.
Yeah. She was intelligent.
No, seriously. Definitely.
She was. Yeah. Now, because I manipulated your formula and changed it up, it has changed what you're going to get. But when you guys do this, you will always get 121 on the bottom. So if you get 121 on the bottom, you've done it correctly.
Yay.
But with us, what was that?
363?
363. And I don't, what was that? 1960 or something like that up at top.
I think so. I believe so. Now that you mention it.
Cool. So, but that's how you're going to do this problem.
Yay.
Now, if it takes us a whole page, this is a big fat hairy deal. Just saying.
I got distracted by the Snapchat for a minute.
Page next.
You're like, Oski Duncan.
All right. Number 7 is way easy. Ignore the millions. Just deal with the numbers that you see here.
That's helpful.
Okay?
Yay. So D is going to be your total sales. So, and that's the D for domain.
Domain.
Okay.
So that's
all of your total sales.
So date.
Right.
The date.
So,
and I don't know why it says the domain of total sales.
Right. That's
and
what
I
was
don't know
kinda,
why.
I was a little confused
Yeah,
on
that
that.
is
I was like,
confusing.
wait.
Yeah.
So total sales is just going to be every single bar that you have.
That's your range. What you're underlining.
Right.
So why it has total sales on both of those, I don't understand.
Okay, yeah, that's why I was. Okay, yep. So that's going to be just your different year inputs, right? Because that's what you're inputting. That's whatever's on the X or the horizontal axis has to be your input.
Yes.
So that would be
your date.
Your date.
Or year, however you want to put it.
Okay.
But why? But I copied that straight from the homework program, so that's what it told. That's what it's got in the homework program.
Mm-hmm. So would you just put like 2004, 2005?
Yes.
And then
comma
do
and
like a
curly braces.
Yes. So 2004, 2005, 2006, 2007. We're being very literal. We're writing all of them. I was going to do ... and I was like, you know what, Austin? Stop being lazy, man. Just write it all out.
It's a pain.
2009. 2009 was a good year. You guys might not remember it. You might have just been born. It was a great year, though. That's when I graduated high school.
That was when I got hired at Somerset.
Ooh, good years for me and Miss April. You guys might have been babies.
Yeah.
All right, and our total sales. So that is going to be all of your output.
Yes.
Right? So 680, 730, and we're just kind of listing them in a brace. Correct?
Yeah. And I wouldn't go ahead and finish writing that because number next is going to take some time.
Do they expect them for this problem to actually add all of these outputs together?
No.
Or just list
them? Just
them?
list them.
Okay. Then it shouldn't say total sales. It should just say sales. I don't know. Actually, total sales
No,
might be okay.
because see, the dark green is 400,
Uh-huh.
and then the light green
So
is
it'd be